So this is the first class maths predicted paper for AQA, and this is the non-calculator paper. And these are all of the topics that we're going to see in this paper. So the link to the paper is in the description. Give it a download, have a go, and then watch along. Question number 1A, write the ratio 7 to 20 in the form n to 1. So at the minute, our ratio is 7 to 20, and this means that we want the number on the right here to be 1. And in order to keep this ratio equivalent, what we do to one side, we're going to want to do to the other. So on this side, we know we will have divided by 20. That's the only way we can make 20 turn into 1, by dividing. And then also on this side, we're going to need to do the same thing. So it is 7 divided by 20. Now 7 divided by 20, let's think of that as a fraction. 7 divided by 20 is equivalent to 35 out of 100. I've times the denominator by 5, so I also need to times the numerator by 5. And 35 over 100 we know is 0.35. So our ratio equivalent to 7 to 20 is 0.35 to 1. Perfect. Question 1b. Divide 160 in the ratio 2 to 3 to 5. So you'll know for ratio, I really like to use little lines like hangman. So we've got 2 little lines, dot, dot, 3 little lines, dot, dot, 1, 2, 3, 4, 5 little lines, and I'm just using this ratio here. Now in total I drew 10 little lines. So the 160 represents all of these, so we're going to take 160 and we're going to divide it equally into 10 little sections, and that gives us 16. So we then know that on each of these lines we have 16. So the first person, or the first section, is 2 lots of those 16, and that's going to be 32. The next section is 3 lots of those 16, which is 48. And the next section is 5 lots of those 16, which is 80. So the ratio that we're looking for here is going to be 32 to 48 to 80, and that is dividing 160 into that ratio. Question number 2, put these numbers in order from smallest to largest. Now some of these numbers are in standard form. This one's in standard form, so is this one, and so is this one, because they're all a number between 1 and 10 times 10 to the power of something. However, the first number here, this one, is not in standard form, so I'm going to make that in standard form. Now to do that, I need the value at the front, this one here, to be between 1 and 10. So I'm going to make it 5.5. But because I've divided this bit by 10, I need to times this bit by 10 to keep the number the same overall. So that's now 10 to the power of 6. And now we've just got them all in standard form. 7 times 10 to the power of minus 7 and 5 times 10 to the power of 6. Now you absolutely can write all of these as ordinary numbers and take them out of standard form. I personally think it's easier to compare them when they're in standard form. Now this one is our smallest, and the reason it's the smallest is because that power is negative, which means it's going to be 0.000 blah 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 instead of being multiplied by 10 lots of times, we're dividing by 10 lots of times. That's what that negative power means. So it's going to be 7 times 10 to the power of minus 7. That is our smallest number. And the next smallest, well, we're looking now at the tens to the power of something, because 10 to the power of 5, no matter what the digit is at the front, 10 to the power of 5 is going to be smaller than 10 to the power of 6. So the next smallest is going to be 6 times 10 to the power of 5. So we've done this one and we've done this one. And now it's between this one on this end and this one on this end, and we've got 5 times 10 to the power of 6 and 5.5 times 10 to the power of 6, and 5 is smaller than 5.5. We're just able to compare these numbers because the 10 to the power of 6 part is the same. So our next smallest is going to be 5 times 10 to the power of 6, and then the biggest is 5.5 times 10 to the power of 6, but I'm going to put it back in the original format that they gave it to me in, just because that's what it would be in the mark scheme, but you don't have to. So if you'd have written 5.5 times 10 to the power of 6 there, you'd be absolutely fine. Question number 3, work out the mean of 2.5, 2/3 and 1/6. So the mean is when we add the numbers together and divide by how many there are. So we're going to add these together and then divide by 3, because there are 3 numbers in total. So I need to do 2.5, add 2/3, add a 6. Now adding fractions, we need the denominators to be the same, but I'm going to first start by making this first fraction top heavy. So 2.5 is the same as 5 over 2. We do the big number multiplied by the bottom number, which is 4, and then add on that top number, which is 5. So 5 over 2, add 2 over 3, add 1 over 6. And the easiest denominator to use here would be to make them all out of 6. 6 is the first number that's in the 2 times table and the 3 times table and the 6 times table. So I haven't changed this end fraction at all. I've kept the denominator 6, so the numerator stays 1. With this first fraction here, we've multiplied the denominator by 3, so I also need to multiply the numerator by 3. So 5 becomes 15. Times that one by 3, so also times the top by 3, good. And with the middle fraction, we've times the bottom by 2, so we also need to times the top, the numerator, by 2, so that's 4 over 6. Altogether then, that makes 20 divided by 6. So that is adding them all up. We've done this bit. We now need to divide that by 3. So 20 over 6 divided by 3. And we know that when we divide, it's the same as multiplying by its reciprocal. You might know keep, change, flip. So now we can just times across, and that's going to be 20 over 18, but we're told to give our answer as a mixed number. So that's going to be 1 whole, because 18 goes into 20 1 whole times, with 2 left over out of 18. And I'm going to go one step further. It didn't say to give your answer in its simplest form, but I think you'd always want to on these ones. We've got 1 whole and 1 over 9, because both 2 and 18 is in the 2 times table. So that was quite nice. When we multiply fractions, remember you're just doing the top times the top and the bottom times the bottom. So that became 20 over 18, and that gave us our final answer of 1 and a ninth. Well done if you got that. Question number 4. W is 10 take away x, and x is an integer, so that means a whole number, where 10 is less than 4x, which is less than 40. So 4x, 4 lots of x, needs to be between 10 and 40. Work out the greatest possible value for w. So let's first have a look at this inequality. If 4x needs to be bigger than 10 and less than 40, then x needs to be bigger than 2.5 and less than 10. And all I've done to get that is divide by 4. But if I've divided the 4x by 4, I also need to divide this bit by 4 and to divide this bit by 4. So there we go. We now know that x needs to be between 2.5 and 10. But w is 10 take away x, and we want to make w as big as we possibly can. We want to work out the greatest possible value. Now, to make w as big as possible, I want to take away as little as I can. So I've got 10. If I took away 10, not that I can because it can't equal 10, but if I took away 9, it'd be 1. That's going to be really small. But if I took away 3, I'm going to get 7. So I want to take away a smaller number as I can. I want to make x as small as possible. Now, it did tell me that it had to be an integer, a whole number. So the smallest whole number that x can be, given that it needs to be between 2.5 and 10, is 3. So 10 take away 3. So the smallest we can make x is 3, so the biggest we can make w is 7. For part B, it says, in fact, x is not an integer, so now it can take a decimal value. So now, actually, we've got some extra numbers that we can use. Instead of having to use 3, we can use some numbers smaller than that. We could maybe use 2.9 or 2.8 or 2.7, 2.6, 2.55, 2.51. There's lots of numbers there, well, an infinite number of numbers that we can use that are smaller than 3, but bigger than 2.5. What effect does this have on the greatest possible value for w? Well, we can make x now, we can make x even smaller. So if I did 10 take away 2.6, for example, we're going to be able to get an even bigger number than 7. So the greatest value for w increases. If we can make x smaller, which we can, then w is going to be able to be bigger. So give a reason for your answer. So we can use a smaller value for x. For example, 2.6. We could use 2.55, 2.51, 2.505, which would make w increase. Perfect. There we go. Question number 5. A is 6, 2, and B is -3, 1. So these are vectors. And remember that in a vector, your top number tells you what to do to go left or right. Negative is left, positive is right. And the bottom number tells you up or down. If it's positive, it goes up, and if it's negative, it goes down. So this vector here the vector 6, 2, is telling you to go 6 right and 2 up. We've got to work out A take away 3B. Now the easiest way to do that is just to write A, which is 6, 2, take away 3 lots of B. Now if I'm doing this vector 3 times, instead of going 3 left and 1 up, which is what this currently says to do, I'm going to do minus 9, 3, because I'm timesing it by 3. I'm making it 3 times bigger. So that means I'd then go 9 left and 3 up. However, we are taking it away, which means we're actually doing the opposite of that vector. So all we need to do now is look at the top. Now this is not a fraction. There's no line here. We're not looking at fractions. We're looking at vectors. So where normally on a fraction you'd make the denominators the same, this is not a fraction. So you don't need to worry about that. So 6 take away minus 9. Now 6 minus minus 9 is 6 add 9, which is 15. So that's going to be the top number of my vector. And then I've got 2 take away 3, which is minus 1. So overall, we've got 15 minus 1. So if I did vector A, and then I took away 3 vector B's, overall, we would be going 15 to the right and 1 down. That is the resultant vector. Okay, 5B, another vector C is parallel to A, but twice the length. Write down 2 vectors that could represent vector C. So vector A is 6, 2. So let's have a little sketch of that. 6, 2 would go 6 across and then 2 up. So vector A looks a little bit like that, for example. Now, if I want to go twice as long, but parallel, then it would need to go 12 across and it would need to go 4 up. So the first answer for 2A would be 12, 4. It's just twice as long. Now you might be thinking, well, what's another one? But if you think about the vector that goes this way, it's still parallel. It's just going in the opposite direction. So instead of going 12 right and 4 up, it's going to go 12 left and 4 down. So that would be minus 12, minus 4, and that would be parallel, just going in the opposite direction. Question number 6, here is a cylindrical container. The container is filled with water at a rate of 0.2 litres per second. Show that the container will be completely filled in approximately 1 minute. So we're talking about water inside the container, and that's telling me that this is talking about volume. So remember, the volume of a cylinder is pi r squared, which is the area of the circle. And then we're going to multiply that by the height, which is this value here, how tall it is. So pi r squared times height. Now we are estimating, okay, approximately, and we've got no calculator for this exam, so we're not going to be expected to work this out exactly, but we're going to do a rough working out. So what I'm going to do is I'm going to change pi. We know that pi is 3.14159 and so on. I'm going to say that that is roughly equal to 3. The radius, well, the diameter all the way across the circle is 20.3. So we're going to say that the diameter is roughly 20, the radius is roughly 10, okay, to the middle of that circle. So times by 10 squared, we square the radius, and then times that by the height. And again, we're going to say that the height is roughly equal to 40. We're going to round that to one significant figure. Okay, so 3 times 10 squared times 40 is 3 times 100 times 40. And I'm going to do 3 times 1 times 4, which is just 12. And then I've got to make it 100 times bigger for here and another 10 times bigger for here. So that is going to be 12,000 centimetres cubed. Now we're told that 1 centimetre cubed is 1 millilitre. So I know that 12,000 centimetres cubed is 12,000 millilitres. And at that point you could change it to 12 litres if you wanted, because 12,000 millilitres is 12 litres, and then you could work with the fact that it fills at a rate of 0.2. I personally don't really want to divide by 0.2s, so I'm going to keep it in millilitres, and I'm going to say that it's filling at 200 mil per second. So I've actually converted that one, and you can do it either way. It's absolutely fine. As long as you get the same answer at the end, you'd be okay. So 0.2 litres per second, 0.2 of a litre is 200 mil. So I'm going to work with that. And I'm going to say, right, if we've got 12,000 millilitres to fill, and we're dividing that by 200 millilitres, what is that going to be? So I'm now going to simplify my fraction, divide the top by 10, divide the bottom by 10, divide by another 10, and I've got 120 divided by 2, which is 60 seconds. So I'm saying that that is how long it would take. Now, that said to show that it takes approximately 1 minute, so I'm just going to put equals 1 minute and then tick and say yes. There we go, we've done it. We're happy that that is correct. So you should still get 1 minute if you did it the other way, but I preferred that way. Okay, question number 7. Solve the simultaneous equations. So for simultaneous equations, we need to solve the value of x and the value of y that makes both of these equations true at the same time. Now it's tricky because x and y can take different values. So while you've got both an x and a y in the equation, it's difficult to work out what they can both be. So the aim of the game with simultaneous equations is always to get rid of either the x or the y. Now in this case, if we look, one is positive 2y and one equation has negative 2y. So it's going to be easiest for us to get rid of those terms. If they weren't the same, we'd need to multiply both equations to make them the same, but here we were quite lucky. So let's write this out again. 5x add 2y equals 18. And 3x minus 2y is 14. Now I'm going to treat these equations like a big sum and I'm going to add them together. The reason I am adding them together is because this one is positive 2y and this one is negative 2y. If I add these equations together, they are going to cancel out and become 0. If they were both the same sign, so if they were both plus 2y, for example, then I would want to take away to cancel them out. But here we're going to add. So I have 8x. And then 2y add minus 2y is nothing. That's the whole reason that we're adding. And then 18 add 14 is 32. So I now know that 8x is 32. And dividing both sides by 8, x equals 4. Wonderful. So if x equals 4, we're then partway to solving our equation, but not quite because we now need to know what y is. So going back to either of the equations, I'm going to use the top one just because it looks a little bit nicer. And I know that 5x add 2y equals 18. But we now know that x is 4. So I can put that in here. 5 times 4 is 20. So 20 add 2y is 18. And let's take 20 away from both sides. 2y would equal minus 2. And if 2y equals minus 2, let's divide both sides by 2. And y equals minus 1. So we now know that y is minus 1, x is 4. Now you can always check it in the other one. So 3 times 4 is 12. 2 lots of minus 1 is minus 2. So you've got 12 minus minus 2, which does indeed equal 14. So there we go. We're happy that that is correct. And we would write on our answer line x equals 4 and y equals minus 1, like that. Question number 8. ABCD is a rectangle. A to B is 32, so we know it's going to be 32 on the top and 32 on the bottom because it's a rectangle. D to E, E to F, F to C are diameters of semicircles in the ratio 5 to 2 to 1. So let's do those little lines again. 1, 2, 3, 4, 5, 1, 2, 1. And we know that that needs to make 32 in total because we can see that that's at the top. So because it's a rectangle, that would also be the length along the bottom. 32 divided by 8, and you might be thinking, well, why are we doing 32 divided by 8? We've got 8 little lines here all together in our ratio. They add up to 8. So 32 divided by 8 is 4. So each of these lines has 4 on it. So the first one is 20 centimetres, because that's 5 lots of 4. The next one is 8 centimetres, that's 2 lots of 4. And the third one is 4 centimetres. There we go. So I now know that the diameter of each of the circles is 20, 8 and 4 respectively. I would like to know the area of each of these white bits so we can take it away from the area of the whole thing in order to get just the grey bit. Now, the entire rectangle, we know that it is 32 long. But how tall is it? We don't have that given to us. Let's have a look here. So I know that this semicircle on the end has a radius of 10. It's 20 all the way across, it must be 10 to there. Now, because it's a semicircle, we also then know that it's 10 from the middle to the top going that way. So I now know that my rectangle must have a height of 10. So 32 times 10 means the entire area of that rectangle is 320 centimetres squared. Now we need to work out the semicircles and take them off. So let's just remove that quickly. For this circle, we would do pi times 10 squared divided by 2. Now the area of a circle is pi times the radius squared. That's the distance from the middle to the edge. But because it's only a semicircle, that's why we're dividing by 2. And that would be pi times 100. So 100 pi divided by 2, and that is 50 pi. We're doing a non-calculator paper, and we're leaving it in terms of pi, so we're just going to stop there for a minute. For the next one here, we're going to do pi times 4 squared divided by 2. 4 because it's got to be the radius, so that's from the middle to the edge of that circle. We know it's 8 all the way across. So pi times 16 divided by 2 is 8 pi. And then for the last little semicircle here, again, from the middle to the edge is only going to be 2. So pi times 2 squared divided by 2, again, because it's a semicircle, and that is 2 pi. Good, so altogether, my final answer would be 320. Take away all of these added together, and that's going to be 60 pi. So 50 pi, add 8 pi, add 2 pi is 60 pi, so 320 minus 60 pi. And we can't put those together, we can't take it off because this is being multiplied by pi. So that is my final answer, 320 minus 60 pi. Let's write it there just because it makes me feel happier. Okay, question number 9. Here is a cube and a cuboid. The volume of the cube is equal to 40% of the volume of the cuboid. Calculate the length L of the cuboid. So let's start. They're asking us about the volume of the cube, so let's firstly work that out. We know a cube is 10 in all directions. If it's 10 on that side, it's going to be 10 going back and 10 going up as well. So the volume of the cube is 10 times 10 times 10. For the volume of a cube or a cuboid, we're doing length times width times height. That is 1,000. And they're saying that that is 40% of the whole cuboid. So 1,000 equals 40%. If 1,000 is 40%, then 10%, to get that, we would divide it by 4, and that is 250. Which means that 100%, always helpful to get 10%, 100% would be 10 times bigger than that, so 2,500. So I now know that the volume of this cuboid is 2,500 centimetres cubed, because I know that 1,000 needed to be 40% of that value. So working backwards, we've got 2,500 as our 100% value. And you can work out 40% of that and check, and it would indeed be 1,000. Okay, fine. So now we need to know what is the length of that cuboid. And again, we're going to get the volume by doing 5 times 10 times the length. So we know 5 times 10 times by L needs to equal 2,500 because we know that's the volume of that cuboid. So that's 50 times by L equals 2,500. So I need to do 2,500 divided by 50. And again, when we divide, much easier to write it as a fraction and just simplify your fraction. So dividing them both by 10, I'm then left with 250 divided by 5, which is 50. So the answer, the length, L, would need to be 50. Question number 10, solve 3 minus 5x, x add 1 equals 0. So here we've got a quadratic, but it's already been factorised for us, which is quite nice. Now we know in order for this to equal 0, these brackets are multiplying together. So it's 3 minus 5x multiplied by x add 1. And if two values are multiplying together to equal 0, the only way that that can happen is if this value equals 0 or this value equals 0. That's the only way that the numbers will multiply together to make 0. So we now know that in order for this to equal 0, either 3 minus 5x needs to equal 0, that first bracket, or x add 1 needs to equal 0. And we've just got to solve both of those. So I'm going to start by solving this one and adding 5x to both sides. So 3 equals 5x, and then we want that x on its own, so we're going to divide both sides by 5, leave it as a fraction because it's just easier, and that is 3/5. If you said 0.6, nothing wrong with that. So that is your first answer, or even easier, let's take 1 away from both sides, x equals minus 1. So x equals 3/5 or minus 1. Question number 11. Okay, the cumulative frequency diagram shows information about the waiting times in hours of 100 patients in a hospital emergency department during March. So we've got to estimate the interquartile range of the waiting times in hours. Now, the interquartile range is the upper quartile, take away the lower quartile, and those are 1/4 and 3/4 of the way through the data. We can see here that there are 100 pieces of data or 100 patients here. The median would be at 50. So we could read across, hit 50, go down, and we can see that that would be at 2.25. To find the upper quartile, we've got to go halfway between that and the top, which would be at 75. And that gives us 2.8. And then halfway between the median and the bottom, which would be at 25. And we can see reading across, hitting the graph and going down, that would give us 1.6. So your interquartile range would be that upper quartile, take away the lower quartile, and that is 2.8, take away 1.6, which is 1.2. Now, there would be a range of answers allowed for that on the mark scheme. So if you got 1.3 or 1.1, you'd probably be absolutely fine on that one. But just take care to be as accurate as you can with reading off of the graph. Okay, fine. So that's 1.2. And then for part B, it says, during April, the hospital recruits more staff to try and reduce the average waiting time. The box plot below shows the waiting times of 100 patients during April. What effect did the extra staff recruited have on the average wait time? Tick a box. So the average wait time is telling us that we want to be looking at the average, and what we've got here is the median. That is the average that we're given. And we can see on a box plot, we know there are 5 values on a box plot. This is your lowest, this is your highest piece of data. Then you've got the lower quartile, the upper quartile, and in the middle of the box, you've got the median. So here we're talking about the average wait time, and that's going to be from this median value here. And we can see that that is 2.25. Now, we already did it on the top one. In part A, we already said that actually the median was here at 2.25. So we can see that actually, despite their efforts, the median, the average, has not changed. So what effect did the extra staff recruited have on the average wait time? Actually, the average wait time remained unchanged. You must give a reason for your answer. So it was 2.25 hours. The median was 2.25 hours before and after. Great. Question number 12. Enlarge shape A by scale factor -1.5 with centre of enlargement 8, 6. So let's draw the centre of enlargement on 8, 6 is here. So we want to enlarge this triangle. Now, if it's a negative scale factor, the shape is going back through the centre of enlargement and out the other side. If I was making it 1.5 times bigger, I'd be projecting it this way, and we'd end up with a bigger version maybe somewhere here, okay? But because it's negative, we're going back through the centre of enlargement and out this side. So I want to count the gap. This vertex is currently 1 down and 2 left. I want to times that by 1.5, but I want to reverse it and send it back out the other side. So instead of going 2 left and 1 down, I'm going to times that by 1.5. So 2 multiplied by 1.5 is 3. So I'm going to go 3 right and 1.5 up. So I've taken both of those distances and times them by 1.5. And that tells me that this vertex is now here. Okay, so now we're going to look at another corner. Let's look at this top one here. And that is currently 4, let's use a different colour. That is currently 4 squares to the left of the centre of enlargement. So we're going to times that by 1.5 and we're going to reverse it because it's a negative scale factor. So we're going to go 6 to the right and that's going to go there. Last corner, and again let's change colour, would be this one, and that's going to be 4 to the left and 1 down. So let's multiply that by 1.5. Instead of going 4 left and 1 down, I'm going to go 6 right and 1.5 up, and we can see that that would go there. So now let's draw that shape like this. There we go. Okay, so removing all of those lines, we can see that this would be the finished article. And if you would like to, you can draw in some lines to show that that always matches up. So you can go from the corresponding points through the centre of enlargement and they will all connect And that kind of shows nicely the twist. You don't need to draw those lines, but it nicely shows our working. That's not essential at all, but it's quite nice. So there we go, that's 2 marks there. Question number 13. The diagram below shows the amount of water in a bathtub as it fills. The amount of water in the bathtub in litres is on the y-axis and the time is on the x-axis. The bathtub is initially empty. During the first 10 minutes, the cold tap is turned on fully, but the hot tap is off. Between 10 and 20 minutes, both the cold and hot taps are turned on fully. So this bit here is showing just the cold tap turned on, and then the bit after from here on is the hot and the cold together. And we want to work out the rate at which the hot tap fills the bath. So first let's look at the cold tap, because we know that this section here is just the cold tap on its own. And the rate of flow, well, let's look at this point here. After 10 minutes, there were 30 litres in the bathtub. So if I do 30 divided by 10, I can find out that 3 litres per minute is the rate of the cold water. Now, if we were to continue that on, after another 10 minutes, we would expect there to be 60 litres in the bath. We can see that another 10 minutes across would be another 30 litres going up. So if it was just the cold tap, we would expect it to continue filling up like that. But instead, we've also got the hot tap flowing as well. So I want to look at this point here and see how much extra water is in the bath. And we can see that instead of it being at 60, it's actually at 110. So that is another 50 litres, which is from the hot tap. And again, that's over 10 minutes. So if I do 50 divided by 10, I'll find out the rate at which the hot tap was flowing in. So I'm going to do 110, take away 60 is 50, which is the extra hot water, or the extra water that is hot, I suppose. And that was over 10 minutes, so 50 divided by 10 gives you 5 litres per minute as the rate of flow for the hot water. Question number 14, and we're simplifying an algebraic fraction. Now, in order to simplify an algebraic fraction, we want to factorise the numerator and factorise the denominator. For the numerator, these terms have both got things in common, so that tells me that this is going to be one bracket. They've got 2x in common, let's pull that outside, and we're left with x minus 2y. 2x times x is 2x squared, and 2x times minus 2y is minus 4xy. So we're happy with that. And then that is over. Now, on your denominator, I've got x squared, and I've got minus 4y squared. And they don't have anything in common to both terms, but we notice that they're both square numbers, and they're being subtracted. Therefore, this is going to be the difference of 2 squares. So my first bracket is going to be x add 2y, and my second bracket is going to be x minus 2y. You can write those either way around, it doesn't matter. I can then divide the top of the fraction by x minus 2y, and divide the bottom of the fraction by x minus 2y, because they have those in common and they're multiplying together, so we can divide by that, and we would be left with 2x over x add 2y. We can't simplify that any further because there's nothing in common to all of the terms. Okay, question 14b, rearrange y minus b to the power of minus 1 equals x. So the first thing I'm going to do here is say, well, what is b to the power of minus 1? B to the power of minus 1 is the same as 1 over b. Okay, we do the reciprocal of b and then raise it to the power of 1, which just keeps it the same. So I'm going to write this again. I'm going to say that this is y, take away 1 over b equals x. Now, there's a couple of ways that you can do this. I'm actually going to say, well, if y take away 1 over b equals x, then I can add the 1 over b and take away the x, or I can just think, well, y take away that is x, then y take away x is 1 over b. And then what I'm going to do is multiply both sides by b. So b lots of y minus x equals 1. And then I'm going to divide by that bracket. So b equals 1 over y minus x. And that would be your answer. B is now the subject of the formula. That goes out the front and everything else is afterwards. Lovely. Question number 15. Teresa needs to collect wheat from her fields. She knows that the time it takes to collect the wheat is inversely proportional to the number of workers that she employs. Last year, Teresa employed 3 workers and it took them 20 days to collect all the wheat. This year, Teresa employs 4 workers and the 4 workers collect wheat for 6 days before one of them falls ill. How many more days will it take the remaining 3 workers? So what we need to know here is how many days would it take one worker? How many days of work is it going to take? So last year, 3 workers took 20 days. So if 3 workers equals 20 days, and I only had 1 worker, it's not going to take 3 times less time, it's going to take 3 times longer. Think about it logically. If you've got 3 times less people, it's going to take longer, isn't it? If I've divided this side by 3, I need to multiply this side by 3. It's inversely proportional. Okay, so that's going to take 60 days. So we know in total it takes 60 days of work to complete this, the collecting of the wheat from the fields. So this year, Teresa employs 4 workers. The 4 workers collect wheat for 6 days before one of them falls ill. Okay, so in those 6 days, there are 4 people working each day. 6 days of 4 workers equals 24 days of work. Of what? 24 days of work. Now, we need 60 days of work in total. So 60, take off the 24 days of work that have been done, leaves 36 more days needed. But we've now only got 3 workers. And if we've got 3 workers and we need 36 days worth of work done, I need to take that 36, divide it between the 3 workers, and that would take 12 more days. Now be really careful in the question, does it say how many days in total or does it say how many more days? And it does say how many more days, so 12 is just our answer for that one. Question number 16. A bag contains the following numbered counters. We've got 1, 1, 1, 1, 2, 2, 2, 3, 3 and 4. A counter is taken from the bag at random and not replaced. A second counter is then taken from the bag at random. Calculate the probability that the number on the first counter taken is a factor of the number on the second counter taken. So you could absolutely draw a tree diagram for this, but it would have 1, 2, 3, 4, and then 1, 2, 3, 4. It's going to get really big really quickly. So instead of doing that, I'm just going to think about the different options that I've got and how many of them I need to work out. So 1 is a factor of 1. 1 is a factor of 2, 1 is a factor of 3, and 1 is a factor of 4. So all of those situations we would want to consider. I've then got 2, which is a factor of 2. I've got 2, which is also a factor of 4. 3 is not a factor of any of the numbers there, other than 3. So 3 is a factor of 3. And 4 is not a factor of any of the numbers except 4, but we're not going to worry about 4 and then picking 4 again, because there's only one 4 and we're not putting it back in, so we don't need to consider that option because it couldn't happen. Okay, so these are all the ones that we need to work out. Now we are not putting it back in. So 1, picking a 1, and then picking a 1 again. Let's do that one first. Picking a 1 is 4 over 10. And then we need to times that by the probability of picking a 1 again. But we're not putting that first 1 back in. There are 4 1s to begin with out of 10. And then if we're taking one of those away, there's then 3 1s left out of 9. For the next one, 1 and then 2, it would be 4 over 10 times, and there are 3 2s, but it would be out of 9 because we've taken one of the 1s out. For the next one, I've got 1 and then 3. So that's going to be 4 over 10. Times 2 over 9, because there's 2 3s, and then 1 and then 4. Now that's going to be 4 over 10 times 1 over 9, because there's 1 4 out of the 9 remaining cards. 2 and then a 2. Well, there are 3 2s, so that's going to be 3 over 10, but we've taken one of those 2s out, so then it's going to be 2 over 9. 2 and then 4, so that's going to be 3 over 10 times 1 over 9. And then 3 and then another 3 would be 2 over 10 times 1 left over 9. So all of these are going to be out of 90. We're timesing fractions, which means we just do the top times the top and the bottom times the bottom. Now, just a point on these top ones. Because these were all of the options of 1 and then something else, you'll notice that these actually add up to, let's do it, 12, 12, 8 and 4. These ones actually add up to 4/10, or it's going to add up to 36 over 90, which is equal to 4/10. Now, it's worth me saying that because you actually don't need to do all of these calculations. You can just say, well, actually, these make 1. So it's just 4/10 times 1. So there is a little bit of shortcut there, but if that doesn't make sense, don't worry, because we're still able to work it out just as we did. So let's add all of these together. We've got 6 over 90, 3 over 90, and 2 over 90. So that makes 36, 42, 45, 47. So all of that added together is 47 out of 90, and that is the probability of it happening. Okay, question number 17. The first 4 terms of a quadratic sequence are shown below: 1, 12, 27, and 46. Now that's gone up by 11, that's gone up by 15, that's gone up by 19. So that's what's happened so far. Now, if the first difference is not the same, then we're going to need to go to the second difference, and we know that happens in a quadratic sequence. So the difference of the difference is that it's added 4 both times. Whatever that number is, we're going to half it. And so that tells us that this is 2n squared. So whatever half that number is going in front of n squared, 2n squared. Now, the the sequence that is 2n squared, we're going to do 1 squared, 2 squared, 3 squared, 4 squared, and we're going to times each of them by 2. So n squared, the sequence n squared, goes 1, 4, 9, 16. It's the square numbers, but we know that our sequence is 2n squared. So it's each of those numbers doubled. So I'm going to say it's 2, and then it's 8, and then it's 18, and then it's 32. So how do I get 1 from 2? I need minus 1. How do I get 12 from 8? Well, I need to add 4. How do I get 27 from 18? I would need to add 9. And how do I get 46 from 32? I would need to add 14. And now we need to look at the nth term of this section. This is going up in 5s. So this is 5n, the 5 times table, take away 6, because it should start on a 5 if it was 5n, but we've got minus 1. So putting those two together, the 2 and the minus 1 makes 1, the 8 and the 4 makes 12, the 18 and the 9 makes 27. So it's both of these nth terms together. So your final answer is 2n squared, add 5n minus 6. Question number 18. Write 77 over root 7 minus root 175 in the form k root 7. So you've got two things to worry about here. First thing is this fraction, which we're going to rationalise, which means to get rid of the surd from the bottom of the fraction. So 77 over root 7. Now, to get rid of that surd, the only way to do that is to times it by root 7, because root 7 times root 7 is 7, but we need to keep this fraction equivalent. So if we've multiplied the bottom by root 7, we also need to multiply the top by root 7, and that is 77 root 7. And now we can see, if we've multiplied the bottom by root 7, we also need to multiply the top by root 7, and that is going to be 77 root 7. So I'm going to put root 7 up here, 77 root 7. Now we can simplify that. They're both in the 7 times table, so that is just going to be 11 root 7. I've divided the top by 7 and divided the bottom by 7. Now to look at root 175. To simplify a surd, we need to find the biggest square number that goes in as a factor, and that's going to be 25. So I'm going to rewrite this as root 25 root 7, because 25 times 7 is 175, and 25 is the biggest square number factor. Now the square root of 25 is 5, so that's 5 root 7, and altogether we've then got 11 root 7, take away 5 root 7, and because they're both root 7, we can actually do that, and that is 6 lots of root 7, which is our final answer. Question number 19. 80 students were asked if they study history or geography. 15% of the students study both history and geography. So of the 80 students, 15 study both, and 15% study both, and 15% of 80 is going to be 10%, which is 8, 5%, which is 4, added together, so that is 12 students. So 15% of 80 is 12. A third of the students who study history, so a third of this circle, also study geography. So this 12 is a third of the students that study history. So a third equals 12, which means that there must be 36 altogether. If we times that by 3, one whole, or all of the students who study history, must be 36. So we know that the circle needs to equal 36, but we've already got 12 in the middle, so that would be 24 left on the outside here. 2/5 of the students who study geography also study history, so 12 equals 2/5 of geography. So that is worth 2/5. 1/5 of the students would be 6. So 5/5, all of the students that study geography would be 30. So we need this circle to equal 30. You've already got 12 in the intersection, so that leaves 18 on the outside to make 30 altogether for that circle. Now, 24 add 12 add 18 is 54. So there are 54 students studying either history or geography altogether, and we know that there are 80 students altogether. So 80 take away 54 is 26. So there are 26 students who study neither subject. They would need to go out here, and that would be our answer. Question number 20. Here is a sketch of the graph y equals x cubed. The graph is translated by the vector 2, 5 to give a new graph. The new graph has equation ax cubed add bx squared add cx add d. Work out the values of a, b, c and d. Okay, so what does this mean? It means 2 right and 5 up. And how do we do that? So thinking about transformations of functions, if I have f of x, a function of x, if I want to move it 2 to the right, I'm going to do f of x minus 2. That's what we know we need to do to the function in order to move it 2 right. And then to move it 5 up, we would add 5 afterwards. So given that our function, f of x, is x cubed, we want to change the input to be x minus 2. So I need to make it x minus 2 all cubed. And then I need to add 5 afterwards. So now I've got this graph. Now that's great, that is correct, but they've asked me to give it in this format. So I need to expand that bracket out. Now if I'm cubing the bracket, I need to do x minus 2 times another x minus 2 times another x minus 2, and then I'll add the 5 at the end. So expanding this out, I would get x squared minus 2x, so minus 4x, add 4. I'm then going to multiply that by x minus 2, so x cubed minus 2x squared minus 4x squared, add 8x, add 4x, minus 8, and then I've got to add the 5 afterwards. So let's sort that all out. I've got x cubed, I've got minus 6x squared, I've then got positive 12x, and then I'm minusing 8, but I'm adding 5, and that's going to be minus 3. So a is the coefficient of x cubed, which is just going to be 1. You can imagine having a 1 there, but we wouldn't write it in. B is minus 6, C is 12, and D is minus 3. Question 21. The equation of a curve is given by y equals x squared minus root 3x add 1. By completing the square, work out the coordinates of the turning point. So to complete the square, we first want to check that there is just a 1 in front of x squared. In this case there is. If there isn't, you'd need to factorise that number out, but we're all good here. And we're going to half this middle number. So it's going to be root 3 over 2. So x minus root 3 over 2 all squared. Then we take away this value squared. So that's going to be 3, because root 3 squared is just 3, over 4, because 2 squared is 4. And then we bring down this value and add 1. So this is x minus root 3 over 2 all squared. But if we're taking away 3/4 and then adding 1 whole, that's going to bring us up to positive 1/4. So the turning point is this value here. Well, what value of x would make that bracket equal 0, which is root 3 over 2, and then this value here, which is 1/4. So it's whatever makes your bracket equal 0, that's going to be your x coordinate, and then just the number afterwards, that's going to be your y coordinate. Okay, question 22, and I think this is the last one. x to the power of 0.25. So I'm going to straight away write that as x to the power of a quarter because I would rather have my indice as a fraction, is cos 45 over cos 30. Now, I find it really easy to remember the triangles as my way of remembering exact values. I know that a lot of people have different methods with tables and all sorts of things, but I personally remember these triangles. So 1, 2, root 3, where this is 60 and this is 30. And then I remember this one, which is 1, 1, root 2, 45, 45 and a right angle there. And what that does is allows me to work out any exact value. So if I now want cos 45, I'm going to look at this triangle here. And we know that so, ka, toa, cos is the adjacent over the hypotenuse. So if I'm looking at 45, and you can use either of them, but I'm just going to use this one in yellow here, the adjacent is 1 and the hypotenuse is root 2. So cos 45 equals 1 over root 2, or you can rationalise that and make it root 2 over 2, but it's the same value, so that's fine. And then cos 30, I'm going to use this triangle. And again, let's use yellow. So we're looking at this angle up here. And again, we know from so, ka, toa, that cos is the adjacent over the hypotenuse. So that's going to be root 3. Oh, I thought I was still in yellow. Root 3 over 2. That's the adjacent over the hypotenuse for 30. So root 3 over 2. Lovely. So I now know that x to the power of a quarter equals root 2 over 2 divided by root 3 over 2. And we know when we divide fractions, we keep, change, flip, and then we can cancel the 2's out because we've got a 2 on the top and a 2 on the bottom. So that's root 2 over root 3. So x to the power of a quarter is root 2 over root 3. Now, in order to work out what x is, I want to actually raise both sides to the power of 4, because then I would just get x on this side, and what we do to one side we do to the other. So to the power of 4, we're going to square it and square it again. That's probably the easiest way to think about it, because doing the power of 2 and the power of 2, we multiply the powers together and that does a power of 4. So I'm going to say if I squared this, I'd get 2 over 3, and then I'd need to square that again, which is 4 over 9. That's the way I think about it. If you want to do it differently, you can say it's root 2 times root 2 times root 2 times root 2 for the numerator, and root 3 times root 3 times root 3 times root 3 for the denominator. And we know that each of these, root 2 times root 2 is 2, root 2 times root 2 is 2. So there we go, we've got 4 on the top and 9 on the bottom. So x equals 4 over 9 is my final answer. Well done if you got that far. That was a really difficult last question, so hopefully that made sense. Please let me know in the comments if you've got any questions. I would love to help. Thank you so much for watching.